All right. Hi, my name is Don Ankney. I work for Microsoft on online services, security, and compliance, and I spend my days talking to developers mostly about how not to do dumb things like allow cross-site scripting. I'm bringing up what's pretty much an old topic. People have been talking about this since the late 90s or so. One, because it's getting worse. Two, because it's becoming more sophisticated. And three, and most importantly, is I hear a lot of really bad advice being given about how to stop cross-site scripting. So please, if you think I'm one of those people giving bad advice, let me know. I'd love to hear better ideas. In the meantime, here's what I've been doing lately in this realm. First of all, this is my work. This is not part of my day job, so don't blame Microsoft if I make an ass of myself. All right, so today I want to talk about cross-site scripting. First is a generic injection attack. It really is the same class attack as LDAP injection or SQL injection. We can address it in that way. Talk a little bit about what makes it unique, how to defend in general, and because you'll see that I spend most of my time talking to developers, I'm going to focus on web application development as the primary defense. Talk about an architectural problem. Do show a little proof of concept tool that I've started that I'm going to turn into an actual, project manager skill set, runnable tool eventually, and where we can go from here. So to define the problem, injection flaws are very common. They aren't just SQL injection, as you most likely know of, or cross-site scripting. You can inject LDAP, XML, Python, Ruby. You see lots of PHP injection attacks in the early 2000s, late 90s. And JavaScript is simply, or cross-site scripting is basically JavaScript injection, just like any of these, and we can address it in that way. Those of you who are developers know SQL injection, we have a better tool there, but like we'd address all of the other ones. So to prevent a single injection attack of any sort, always keep track of your trust boundaries. Know what is your application, what is not your application, and don't trust anything that isn't your application. Validate or sanitize your inputs. They're two different things. A lot of people don't make the distinction. Validating your inputs says true or false, this input meets my expectations, and sanitizing says take this input and make it meet my expectations. The former is going to be more conservative from a security perspective. The second is going to be more liberal, but there are business cases for both. Properly encode your outputs. That means first knowing what your outputs are. Commonly that's going to be HTML, but you may be putting things into an XML feed, maybe putting them into a JSON object, whatever. So you want to encode properly for whatever your output purpose is. You want to use whitelists, not blacklists. If blacklists work, we would have solved spam by now. So a whitelist, for those of you who don't know, is saying, here is what I expect. Anything that matches is good. Everything else we exclude. A blacklist would be saying, here are simply known bads. And there are more bad guys, and there are people working on the white hat side. So whitelists, again, are always the best way. Exercise the principle of least privilege. That means everything should have only enough permission to do exactly what it needs and nothing else. That doesn't just apply to user permissions. That also applies to your whitelists. Make them only as permissive as they need to be, and no more permissive. And just general web application is validate your assumptions. A lot of people, where I'm seeing cross-site scripting errors, people are assuming they're outputting to HTML, relying on HTML encoding entirely as their defense, and then the application changes and they have to output XML and then their host. So trust boundaries, just a quick diagram to show what I'm talking about is your application is the triangle and everything outside is a trust boundary. Every time you cross a trust boundary going in or going out, you need to do something to make the inputs either validate, sanitize, and encode. And keep in mind that it's not just web requests. Coming from the user is forms, headers, cookies, AJAX, files, anything that comes across. Your database isn't necessarily SQL. There's LDAP. There are web data stores, fancy sort of SkyDrive things like we have at Microsoft. And your system isn't just files. Think about things coming from other processes if you're in a complex environment, as well as any services. So cross-site scripting is a little different than most of these because most injection flaws, if you're thinking SQL injection, are attacks against your server. They're changing the state of your server. They're getting data from your server. They're injecting data into your server. And cross-site scripting directly injects into your client. That means your end user is bearing the brunt of this attack, and it runs arbitrary code in their browser. And if you're involved in a business environment, keep in mind that that browser is behind your firewall, and an attacker is running arbitrary code on it. So they can do anything that your user can do. They're acting in that user's security context. So this is really the input or the impact if you're working in a corporate or a business environment. There are nasty things you can do, and this is just a stock slide I'm sure everybody's seen before. You can control what appears on screen, forge an authentication interface. You have access to the history, so if you've gone to a site that stores its session token in your get statement, it's in your history, they now have your session and can act as you on that application. It can intercept your cookies if people have designed the application poorly, and it can enumerate your network. You can simply say what else is on this network that I can reach from the client browser, and any server that your user can reach, the attacker can now reach through JavaScript. So a quick overview of what cross-site scripting is. The first type is reflected cross-site scripting. So an attacker sends an attack string URL, commonly in a phishing attack, to a user who clicks on it. It goes to sends the attack to the web application, and the victim browser will render whatever the attack string is. And commonly this will be to execute JavaScript from a third-party site, say evil.com. This is a non-persistent attack, so it doesn't persist across users. Only the user who clicks on the link or the link is loaded for them, think in the context of an image loading, is a victim to it. It only works in the context of a single session. It doesn't persist across them, and it only works on a single page, so it's only the page to which the person clicked. It only affects the user who submits the malicious URL. It's not something that can cross user contexts, and this is really relatively easy to detect via a scanner or a fuzzer. Most of your cross-site scripting things you're going to see that are doing web application vulnerability scanning are scanning only for this type of cross-site scripting because it's a single, I send you a piece of data, I get something back, and it's very easy to evaluate whether or not there was a vulnerability there. The second type is persistent cross-site scripting, where an attacker will send an attack string to a web page, not to a user, but to a web page, where it gets stored somehow, usually in the database, and then any victim who looks at the vulnerable page will see this attack string and have whatever that JavaScript is executed in their browser. So here we have something that can persist across all three of those variables, the users, the sessions, and the pages. It can depend, I mean, those aren't all 100% true on the context in the application, but this is the most dangerous in the sense that if I find one vulnerability, every user who goes to that page is affected, so it's much more widespread. And it's very difficult to attack via scanning and fuzzing because it's usually not the page where you submit to, but another page that can be the victim page from this. So there are a lot of paths through an application where data can go, and scanning would create a lot of noise because you have to inject to every page in a system and then scan to every page of the system. And you'll see that's part of what the little tool I put together, the proof of concept, does, and you'll see the logs, how it just flies through for even a small number of pages. And generally, this is best identified by code analysis. There's now a sort of a third group of cross-site scripting that I'm seeing in the wild now, which is a sort of hybrid between the two. And it is a form of persistent cross-site scripting, but it's not stored in a database. It's stored in something that's tied to the session. So it's only good for a single session. An attacker sends an attack URL, like they would for reflected cross-site scripting, to it. It gets clicked, it gets loaded, whatever. It goes to a web page, stores in the session data. And this might be session data that's persistent in RAM on the server. It might be written to a temporary file, it might be stored to the user cookie. But it's not in the database, so it's only persistent for the session. And then when they either go back to the same web page or to another web page, then they're a victim of this attack. And this is really insidious in that in many cases, the order in which you go through an application will depend on whether or not you're vulnerable to this attack. It becomes very difficult to detect these from the outside because you have to then enumerate a web application through every possible sequence of pages with every possible input. And if you just think about the math of that, 10 pages get something like 10 billion possible combinations there over a TCP connection, even on a virtual machine. That takes a lot of time and is incredibly noisy. So this would not be something you could do in a production environment. Second, as I've mentioned, these do not persist across sessions. They do persist across pages. They may persist across users. Sometimes session information is tied to the who's currently online functionality. So if in that case the username were allowed to be, or were vulnerable to cross-site scripting, other people could be impacted by the hybrid XSS attack. And for reasons I've just talked about, this is extremely, extremely difficult to detect remotely. Detecting injection flaws remotely have a couple of ways of doing it. Pretty much scanning, I think I've pretty much already talked about. You have a simple fuzzer which sends an attack screen and checks for appropriately encoded returns. The most difficult part here is maintaining a list of current attack strings. There are lots of them out there. My favorite happens to be the OWASP project, the Cal 9000, which allows you to build attack strings, customize, and even try and create your own. But there's a fairly comprehensive current generation of attacks that's available through that. And it's basically checking when I send an attack string, does it come back in a way that will be executable by a browser? Scanning for persistent vulnerabilities is really really immature at this point, simply because when you're scanning from the outside, you can simply look at cause and effect. You have no internal representation of the data. You don't know what's currently in the database. You don't know where the flaw is. You don't know if this is in when you're doing your sanitizing, or if this is when you're doing your encoding that's causing the flaws, causing the flaw. And also, again, it's extremely noisy. So it's either going to hose the site through a denial of service. It's going to make very clear the site's been attacked by having strings scattered all the way throughout the application, or it's going to trigger something in a log, hopefully. The system administrator is watching for lots of attack strings coming through in their logs. Detecting injection flaws locally is much more interesting here because it works across techniques. You have static and dynamic code analysis. Static code analysis looks at the source code. Is there something that's known to be wrong in the source code? And a dynamic analysis is about the application state. What is the current internal representation of the inputs and the outputs in the application? Static code analysis, most basic technique is manual code review, right? You're going to go line by line through the code and try to find places where something doesn't look right. And you'll see an example of some code that simply doesn't look like, even though I used one of these tools to find it. And then you have static code analyzers. Pixie works on PHP 4 compatible. Cat.net is a Microsoft tool that works on ASP.NET. Then the Code Secure is another commercial tool that works across several languages. And there are many of these. If you have multiple developers, you actually have development culture at your company or in your environment, find a tool that works and make it part of your testing process. Static analysis looks for several things. First, we're looking at input sanitization. You can't really decide if it's good or bad input sanitization with a static code analyzer. You could tell simply, is it there or is it not there? It comes down to the limits of computability as to whether you can't really know what the code does without executing the code. You can check for output encoding and making sure that both the application, this is HTML outputting, so HTML encoding, and the character encoding. So are we rendering this as UTF-8? Is this going to be a multi-byte encoded output? And we could look at the data flow. Is there anything that comes in from a user, stored anywhere, processed anywhere, that goes back to the same user or another user without crossing both of our bits of code for sanitization and output encoding? If it does, then you have a vulnerability path. It's not necessarily a vulnerability, but it's worth looking at through a manual process to look at the code as it goes through there. Dynamic code analysis is really the only way to consider application state, which impact means it's also the only way to really look at persistent and hybrid cross-site scripting. You can find some of it in your code analysis through static code analysis, but if you really want to see what's happening in the application, you have to go dynamic. And remember that the internal representation of the data is the most dangerous point, because whether the cause and the effect are the results, but if you're developing an application from scratch, how that application is, how the user input and output is represented internal to the application is really what generates the risk. If you're storing it in an inert state, which absolutely cannot be executed no matter what, then you have to do something to make it executable in the browser. So it makes it a much safer way to do things. There aren't a lot of existing tools. There are most of them that are intrusion prevention system style things. You could think about can't believe there's a product I'm blanking out that's a .NET base that runs between IIS and .NET that won't allow you to execute any code that's vulnerable through signature-based things. There are web application gateways that can be either at the incoming or outgoing perimeter that basically look at state. There are lots of ways to do it that are intrusion protection, but very few that will help you develop better code in terms of dynamic code analysis at this point. Defending it cross-site scripting. And this is really, I hope, to be the meat of the talk here, is that there are 3 control points for cross-site scripting. You have the browser. Browsers don't necessarily render things the same, and browser manufacturers, frankly, need to do a better job than they are about writing browsers. You have the web application itself. This is where the developer, your developers, or you have a bit of control over things, since you can't tell all the browser companies what to do. And the third is the IT infrastructure. Are you going to put up an application gateway? Are you going to look at triggering things in your logs? Are you going to put defense in depth techniques in place that can stop things that you know about? And you can mitigate cross-site scripting at all 3 points. So there's a call to action for anybody who's involved in an IT enterprise. The browser, they all execute different code snippets differently, or do not execute certain code snippets. The first one here, the body background one, that's really pretty clear what it's doing, will execute in IE6, not IE7 or newer, Opera 9, but not in Firefox. The second one will execute in Firefox 2, but not 3, Opera 9, but not any of the IE versions. And that's a base 64 encoding attack. So when I said the most difficult part of scanning is keeping track of attack strings, this is what I'm talking about. There are thousands of variations on these. They'll execute in some browsers and not others. And the current browsers, to be fair, are much better than the previous generations. Both Firefox 3 and IE8 do a much better job of not executing malicious JavaScript. In IT infrastructure, I think I've already mentioned you have web application firewalls, things that sit either at the perimeter of your users' network space. So every time they go to a website, if something comes back and it matches a signature, they won't let them execute the JavaScript, it'll block it. There are intrusion protection systems. Snort will do a bit of this. They will do the same thing. If you have all of your routing going through Snort, it'll stop bad or malicious code from reaching the browser to be rendered. And you have the web application sandboxes. Google's got a couple that they have. Microsoft has a couple that are being floated right now in research. And there's the one commercial one whose name I can't believe is escaping me. But remember that all of these are signature-based defenses. That means they're about as effective as your antivirus is, which is to say they will catch, at best, 80 to 85% of attacks, and only known attacks. Anything that's new or novel will skate past these. This is why I would like to consider IT infrastructure things as defense in depth mitigations against cross-site scripting. None of these technologies can solve it. Web application defense is all about process. And this is a design pattern that I like, and when I try and teach people, I try and do a lot of outreach, especially to the PHP communities. This is what I suggest to them that they do, is they first write new code. Any bad code, it's better to start over, I think, if you have systemic problems and design from scratch. Keep the same features, keep the same specs, but it's very difficult to clean up old code. It's much easier to write new code. So you get a request. The first thing you do is you decode it, then you apply your security checks, your business logic, do what an application does, encode it, and return it. And I'll step through it in a moment, but I will say that if you are using classic ASP, JSP, PHP 3 and 4, things where all of your processing is happening right on the presentation layer, you take an input from a user, and you process it on the same page of code in which you return it. This sort of thing is very difficult to do. MVC code design and even object-oriented code design, if you want to do it that way, will work with this process, but the old Perl CGI stuff from the 90s, that style of coding is very difficult to be systematic about following an architecture like this. So first you have to decode your input. In the headers you're going to find that the browser that is submitting the request is going to tell you what they'll take back. And in general, you probably want to encode to that browser at the end, so keep track of that. And it's also probably going to be the encoding they're using to send the request. It's an assumption that I'm making, but it's probably a pretty good one, and really in this pattern, it only matters for usability's sake that you try and match their encoding. The default is ISO 8859-1. You probably are using UTF. I tend to use UTF-8 when I'm coding as my internal representation. So the first thing to do is, if there's any decoding for what they're telling you they have to what you do internally, is you change it so that the input is considered to be rendered in your internal representation. The second is your security checks. So you have this request that's now represented in the same way that you do all your data tracking and processing internally, and you apply your whitelists, which is to say, you say, here is my HTML that I want to allow. Very safely, most people want to allow people to post to a message board, for example, using basic bold, italic, these sorts of things, and there's really not a lot you can do with them. So those are on the whitelist, and you can imagine the riskiest bits of HTML are things that are tags like script, obviously, or something like image, or anything that will load something from an external resource, it being at the riskiest. So your whitelists are about your business need. Make them absolutely as strict as you can. And if you actually have to accept things off-site, I would consider even whitelisting which domains. If you want to allow embedded pictures, great. Allow SmugMug, allow Flickr, choose a couple, and force your users to use them if you can get that by the usability people. Allow YouTube and Vimeo, maybe Google Video, whatever you want to do for your video, but don't allow things to be embedded from, something.ru. Whitelist where you're going to accept things from as well. And sanitizing your HTML, which is what I'm sort of alluding to here, is saying here's the request, the message that I'm being sent includes HTML tags. And there are libraries that will do sanitization for you in .NET, Microsoft Anti-XSS, the OS Anti-SAMI. Currently in .NET, Java, and Python, there's a spec out for PHP. There's nothing even in beta yet, and the Python is only in beta here right now. And then in PHP, there's the HTML purifier. This is a bit of coding, but like cryptography, is very, very, very difficult to do exactly right, but very easy to do almost right. So if you can have something that's maintained for you, I would use a third-party library. It'll save you nightmares in maintaining your own code later. If you do have to write your own, as I mentioned before, whitelist HTML tags, be as restrictive as possible, and if you can get away without high-risk tags such as the anchor or image, please do away with them. Then once you've got that, though, and here's the fun part, is don't store them that way. Replace every single whitelistable tag with a symbol of some sort, something that won't be changed by HTML encoding. So you're storing them internally in a completely inert fashion. If you want an anchor tag, you can simply put some nonsense garbage that won't be recreated in any sort of usability sense, followed by the word anchor, followed by an end tag there. And you also will probably want to take the input. So an anchor tag is going to go to a URL. Don't store it internally. Don't take the HTTPS. Actually parse that. Look, here's the domain, here's the path, and store those separately. So the goal being that eventually you're not actually going to reflect any user input at the end when you return the request, but you're going to have things that are constructed programmatically by you, because you trust your own code more than you trust the user's input. So anyway, we're going to get rid of high-risk tags. Anything we have to accept, we're going to store as symbols. Then we're going to encode the output at the end of these security checks by taking these the first thing we do is HTML encode everything that is not trusted, which is anything that has not been whitelisted is not trusted. So if I have a tag that we didn't consider that is not part of our whitelist, it's still there, we didn't erase it, but it's going to be HTML encoded in the HTML in the web context, and return just a bit of text on the screen that they'll read that will not be acted on by the browser. After we do that, we can take these symbols and replace them with the tags that we're writing that aren't user inputs. We're not just doing regex to find, regex to replace. We're actually constructing our own URLs, our own tags, and put those into the request. So anything the user has sent has been HTML encoded. Anything that we want the browser to take action on, we know that the user wants us to take action on, and then we construct it from within our code that we control, we trust, and then we add it back into the stream. So that anything we miss, anything that was not whitelisted is going to be HTML encoded and inert. Anything that is rendered by the browser is going to be something that we wrote that isn't user input. It's simply we've taken decisions in constructing this based on the user's input. And then you need to explicitly declare your character set. A lot of people assume that their web server is configured to do this for them. A lot of times it's not. In Unix, you can usually do this from within your user context, even in shared hosting, in your .htaccess. I have the code right there. And if doubt, every single language can override the web server, so you can explicitly do this within your web application. And this is enormously important, especially if you're serving communities that use non-Latin character sets. If you're going to be deploying your application to Asian countries or to Russia where they have multi-byte encodings, you really want to make sure you do this, because this is the #1 cause of cross-site scripting that I'm seeing, is the errors in not explicitly declaring the character set. And things are encoded in a character set the developer doesn't read natively, they're going to miss things. So please explicitly declare. It's an extra line of code. Just make sure you do it. And the most important thing, I think, is to check do your security checks actually work. This is a bit of code I found in a popular CMS that I think this fork has actually been abandoned because I haven't gotten anybody to respond to the fact that I pointed out that this doesn't work. And this has a number of things wrong with it. Are there any coders here who can tell us what's really, really, really wrong with this? The PHP, which means you have to roll it yourself. You can't use a managed library. Yeah. This is like line 30 or something in their index.php file. So this is like the first thing they do after their comments. It's a blacklist. It's blacklisting script, object, iframe, applet, meta, style, form, and I can think of a lot of ways to do nasty things without those tags. You notice that get and post have different blacklists, so that they care more about gets than they do about posts. Their posts are only a couple. They only care about script, and for some reason, style tags for posts. Gets they care about a lot more. How about there's no character encoding? So if I even don't want to use script, all I have to do is encode it in a way they're not expecting. It's going to come through, and the browser is going to render it. Yeah, this is pretty bad, and this is their complete cross-site scripting input sanitization right here. So make sure your security checks do what you think they do. Fuzz them, test them, run them by your peers. Or better yet, use one of those managed code libraries. I guess even PHP has the sanitization libraries that are available to you. And in testing the architectural pattern I just mentioned, I just brought a proof of concept thing. Like, so what I'm going to show you now is it's PHP code, so there's really no user interface to it. And as it becomes more sophisticated, I'm going to put it into C#, give it a point and click interface, make it usable to people who don't write code. But basically, I want to put an application, since I'm a developer, I have my source code, I'll put it in a virtual machine, and I want to fuzz it. And in a sense, this is also a dynamic code analysis tool because we're going to track internal representation by looking at their database. But we're going to take attack strings. We're going to send them to a target application, which will then store them in the database. And then we're going to look in the database and see, were these actually changed, or did they make it past the sanitization checks? Are they stored inertly in the database? At the same time, we're also going to be able to find, since we're crawling, are there any reflected vulnerabilities? Are there any persistent vulnerabilities? Because I'm actually going to crawl this one twice. We pretty much get those for free by this approach. And then I'm going to do the reverse. I'm going to take the attack strings, I'm going to insert them into the database, and it's going to completely foobar the application for usability, because you can think of cases where, things are joined on keywords that are now attack strings. But we are going to see if anything gets reflected out to the user by then crawling the website again. Within the virtual machine. It's not much to look at, and the actually, let me pull the tail up so you can see what's happening on the there we go. Hold on just a second, I need to log back in. And of course, it worked this morning, but it's Right, apparently he just was having trouble coming out of sleep there. And I just have a couple of attack strings. There are 3 things here, 2 of which are real attack strings. The third one is just a plain text string to make sure we can track. And you can look at those requests fly by on the log as this is a default WordPress 1.5 installation. There are like 4 pages on it. And we have a lot of requests flying by. And you can see that it's found you can see the words here, fake attack string. Well, that's my fake attack string because I didn't want to make you watch the thousands and tens of thousands of requests to go through a real database of vulnerabilities. And in fact, this does have a couple of known vulnerabilities, but they're in the admin interface, which we're not fuzzing at this point. So not going to be showing you any real vulnerabilities in version 1.5. And then I primarily chose 1.5 because, well, WordPress is cross-site scripting central usually, but the current version uses mostly AJAX to send things back and forth, and AJAX is one of the limitations of this code at this point that I need to expand. So we wouldn't have gotten a lot of value at looking at the current versions. So the default installation should have one comment. There are currently 13. And you can see where it's doing the fuzzing and why you wouldn't want to do persistent cross-site scripting in a production environment because, like I said, this is 3 attack strings. And it found persistent and reflected on the fake one. None of these actually work within WordPress. To do the inverse now, if I want to look at the database, first I have to restore to a clean virtual machine. And it would work without the clean virtual machine, but we get false positives on everything we've already injected into the database. It helps to run the right file. Oh, did that actually? Well, this one might be failing, of course, in demo. Let's check to see what the website says. Well, no, it looks like it worked. My verbosity must have failed for some reason there. It's putting things that it shouldn't, and these are things that are in the database. But basically, what we found is that this version of WordPress doesn't do any input sanitization. Everything will make it to the database cleanly and be stored in an active sense, not in an inert state. So that they're relying entirely on doing their whitelisting and their encoding both on output, which actually works in this case for the most part with their known vulnerabilities, except for the fact that if this were ever extended by another set of developers, they're dealing with data that's unsafe. There are a number of, in WordPress's cases, plugins that will access the database and pull things out. So an example of why you would want to always store things. Yes? Oh, this is 1.5. Yeah, the 2 branch went to mostly AJAX inputs, in which case this tool is completely useless. Yeah, I do have plans to build it out for AJAX, and I have plans to add some authentication. Actually, that's probably the next slide. Well, I'll skip to my tool plans. Again, give it an interface, put it in C#. I want to be able to do multiple authentication forms, add some OpenID support so we can do things via token as well, some web forms, and expand it for both AJAX and also be able to fuzz headers. Yeah.
What's your plan for doing the AJAX and JavaScript stuff? That seems to have been difficult for analysis.
.NET is your friend. .NET. The .NET Managed Framework has some pretty good AJAX classes to it, so it takes the difficulty out of building it. Yeah.
Are there advantages to cookies versus encrypted URLs for session authentication?
Versus encrypted, yeah. If the session authentication is an encrypted URL, it's available via the refer string if the token's in the URL. So that if I go from your site to evil.com, I can see what your token is and then act with that token. That wouldn't be true of headers, for example. It's not true of cookies. And if you're doing things via post with the hidden form, that's with the hidden value is another way to store a session token without putting it into the header. Yeah. SSL won't mitigate cross-site scripting because you're going in through the front door. Right? You can have an encrypted request, but it's still, when it gets to the server, it's still the same attack string. Yeah, cryptology won't solve anything. Almost all these applications have sidejacking things that are broken as well, and that's where encryption becomes a big deal in terms of security design. Otherwise, its most important feature is keeping your data secure from information disclosure. So, I guess I take that back. If you could build a web this way and talk your business into doing it, use X509 certificates to do authentication via SSL, and you're in beautiful condition about authentication and so on. But I have had no luck. I don't know if anybody else has had luck talking businesses into completely certificate securing all of their web space. So go back. I think I covered the benefits mostly. There are fundamental problems in software design that defines by examining state. We can look at is all the attack data being stored inertly in the database. We don't have to care about noise. We're just doing it in a virtual machine in a test environment. And if we have the code, or even if we're working on an open source project, we can implement this pretty quickly. And we actually detect persistent cross-site scripting fairly quickly via this approach. Limitations, again, forms, AJAX. The cookies can be fuzzed, headers can be fuzzed. There are lots of ways data gets in there. The thing I haven't figured out how I want to do is looking at things that use JSON. I haven't quite figured out how to build an effective fuzzer there. So if everybody has any ideas, I'd love to hear that. And so this is clearly solvable. I mean, this web application pattern is pretty quick and easy. Anything, as far as I can, in my analysis, it'll solve pretty much 100% cross-site scripting if you implement it with dedication. Legacy applications, like I mentioned before, don't lend themselves to this pattern. If you're writing, embedded PHP in HTML in the PHP 3, early PHP 4 styles, or if you're writing classic ASP, or to some extent, Perl CGI in the 90s style, your host, you can't really do this. Browser behavior can be a problem. Is solving it today doesn't mean that the next generation of the browsers won't screw something else up. Current generation is pretty good. I found that they're updated, and as soon as a cross-site scripting vulnerability is found in both Firefox and Internet Explorer, that they're patched pretty quickly for it. Application complexity makes it very difficult to predict state like a client application. I mentioned before the idea of going through and trying to find the hybrid cross-site scripting attacks that you pretty much have to enumerate every single possible route through an application. And as applications get thousands of pages, and then that just grows exponentially. And complexity also involves developers. The more developers on a project, the easier it is to be lax about following an architectural problem. So there are a lot of culture of quality engineering work that needs to be done to make sure that everybody's doing the work they know to do. And the applications change as the developers change over time. I mentioned briefly that WordPress plugins are a big vulnerability because they tap into the database and do whatever the heck they want on the way out without necessarily going through WordPress's quality control points. And simply because the current developers, no one follows this pattern doesn't mean the next hire is going to, or even that you're going to own this code for its entire life cycle. So call to action, write better code. Pretty clearly, it's a lot of work, but it's not difficult once you think about it and know how to do it. Use current browser technology, and this is really important, both the personal browsing of the web and as an enterprise, make people upgrade their browsers. And honestly assess your enterprise. I mean, this is looking not just what are we building now, what have we built in the past, do we need to tear this apart and rebuild it to solve cross-site scripting? Do we have lots of legacy code that we're not going to be able to find an easy solution for? Or is this something that's going to be so cost ineffective we should put in something like a web application firewall or Snort to actually kill requests that are going to be getting signature detectable cross-site scripting attacks in our enterprise? My contacts, bibliography, these are people who are smarter than me, so you shouldn't, if there's something that I'm not addressing, you want to hit these sources. Most importantly, I think actually Michael Ernst, the second and third link down, just moved from MIT to University of Washington. I discovered these papers last week, and they're basically about 2 years beyond where I am thinking about the same things. So they're fantastic papers. His tools are better than mine. He has a half dozen CS graduate students writing them for him. Yeah, so I'm seeking to see if I can talk to him and get some to push my own work forward. But I think this is important work, and then more bibliography. And any more questions? I'm sorry? Oh, hit my blog. I have a personal Subversion server. I just didn't want to put anything up until I gave the talk. I'll probably just put it in my personal. Yeah, Codeplex complicates things for me because I did this completely on my own time, and then I hand licensing over to Microsoft since they pay my rent. And I don't have complete control over what to do with it. Any other questions? I guess that puts us ready for lunch about 15 minutes early. Thank you very much.